Hello, beginning linear algebra students. I'm looking at section 2.1 from the book Linear Algebra with Applications, which is an open educational resource found at this website. I'm going to show you matrix addition, scalar multiplication, and transposition using Desmos, and unfortunately I already made the video once and it was 12 minutes, and I try to keep mine down to 5. So I'm doing it again, and I'll have to split it. But I wanted to show you, okay, this was a previous example, and I wanted to show you the numbers. It's always row by column. Row has one syllable, column has two, so row comes first. So rows, we have 4 rows, and then 5 columns. And I went to desmos.com, and so here's that same matrix, and then I just kind of made this one up. So I'm going to show you matrix addition and subtraction, what happens if you multiply by what we call a scalar, and what happens if you transpose. So that's the matrix addition, and adding a negative is the same as subtracting, scalar multiplication, and transposition. So I'm going to go to desmos.com. So here are the two matrices that I put in. And let's start with scalar multiplication. 2a. You can see that I really did just multiply the 1, 1, 1, negative 1, 3 by 2 to get 2, 2, 2, negative 2, 6. And if I went on the bottom row, 1, 3, negative 4, 3, negative 5 went doubled to 1, 6, negative 8, 6, negative 10. And that's why I can say that a negative 1 times a b, so you can see that I just multiplied everything, just change the signs of everything, can let me do a minus b. So I needed to show you that. Now it's really important that a and b are the same size when we try to do this. So looking at this, let me pull up a again and b. So I get for making the screen a little bit smaller. Okay, so when I add them, oh no, I said b. Okay, so when I add, I'll have 1 plus a negative 2, 1 plus a 2, 1 plus a 3, negative 1 plus 2, etc., etc. I just grab each one in its the same spot, same location. So this is cell 1, 1. This is cell 2, 2, 3, 3, 3, 4, which means row by column. Third row, fourth column. Third row, fifth column. Let's see, here's 7. And third row, fifth column is 1. So when I add a plus b, I'll have 7 plus 1 to equal 8. All right, so a plus b. And here we have third row, fifth column. Sure enough, we have 8. So let's just bring this up. Let me just pick this one down here in the far left corner. 1 plus 0 equals 1. 3 plus 7 equals 10. Negative 4 plus 0 is negative 4. And let me go ahead and do a minus b. A minus b. So right here we'll have, let's see, 1 minus a negative 2 makes a positive 3. And looking at 1 minus 0 should just be 1. Oh, that's the plus. 1. And then 3 minus 7 equals negative 4. So that's how we can have our matrix addition and our scalar multiplication. Now let me show you what A and A transpose look like. So the first row was 1, 1, 1, negative 1, 3. When I transpose it, the row becomes a column. And instead of a 4 by 5 matrix, I now have a 5 by 4. It's just kind of flip things around. Now the things that don't change are the ones that are on the diagonal. Pretty much. It's a little bit harder when it's not a square matrix, but let's just look at the last row right here. 1, 3, negative 4, 1, 3, negative 4, etc. And the same with B and B transpose. So this is what we have. And let me show you why it's so important to have the same dimensions. Because, right here we got a 5 by 4. Remember, I can add A and B. But if I try to add B transpose, I get a warning that says, you don't have the same dimensions. That's because I'm trying to add a 4 by 5 to a 5 by 4, and they won't. No, they just, we can't do that because we don't have places that we can. Here we have 5 and 1. There is no 5 and 1 cell in B or even A. A, yes. So we can't do the addition or subtraction. All right, I'm going to show a couple more definitions in part 2.